Hello and welcome to this year's Autodesk University. I'm Stefan Ivanov, a professional 3D artist. And this year I'm going to present how am I creating a procedurally generated assets using scanned data. I'm going to talk about the whole process, the different software which I'm using, and as well I'm going to present you a little bit about my workflow. The creation of procedural assets and having the ability to create something which fits exactly the need of your scene, but as well is photorealistic and it looks exactly how it will look on the real life, is something which is very interesting for different areas. My expertise are mostly in game development, but this is something which can be useful for visualizations or cinema. In this presentation, we are going to look into some of the steps which I'm taking along the way when creating such assets. I'm going to show you my work in progress and some of the tools that I've been using. And also, I'm going to talk how Autodesk and especially how some of the softwares that Autodesk team is developing are helping through this process. Now, without further ado, let's start on the first topic. And this is going to be the planning for creating scanned assets. Before starting to create the tools and how exactly the assets are going to look like, we need to understand two different factors. First one is to collect the correct data from the specific region or specific type of architecture if we are doing an architectural elements. In my case, I'm going to be showing you a ruins of a castle and I'm going to show you how that castle looked before, which is going to be something as a reference point. And I'm going to show you how we scan a small portion of it. And from that portion, we can recreate different types of assets that later on can be assembled in different modules, and you can generate endless versions with the same style. So, as I mentioned, one aspect is our scanned data. Another part is the research which I'm putting behind, and this research is the architectural research. This is something which, how exactly from this period, people were building those structures. The further we go in the past, it's something which is harder and harder to find evidence, but as well, it's something which is more and more interesting to research and discover how exactly people were building, for example, different castles or different type of fortifications or structures in medieval times. That research from my side is something which I usually go on site and I start just measuring different proportions, measure different types of stones, and as well see how exactly they are being aligned. I take a lot of reference photography, which later on I'm using to put into the algorithm to teach it how exactly those stones are being laid for creating this type of walls. And also because this structure from medieval time, they already have quite a lot of erosion on top of them, we can see how weather and other effects played their role into shaping the stones and creating the look which they have nowadays. Another research around the architectural part is about the materials. Since we know already from what materials a certain structure is being created, and we know how it eroded, we can then recreate and go back in time and remove the erosion and create a newer version of these materials. All these things that I mentioned are different layers into creating a procedural asset. Now let's talk a little bit about the scan data which I'm collecting. For this particular example, which I'm going to give you, I made a little bit over 2000 images from the same area. Some of them are taken just for being references, while others are being taken for scanning a different part of a wall or some part of a structure. All the images that are being taken for creating 3D assets, I use Recap to calculate and create this data. Once the data from Recap is being calculated, we get a couple of things. We get a high poly version of the asset, and as well, we get a set of textures. We can use these two to create different variations of this asset or just create a small portion of it. For example, if we have a whole wall, we can just cut one stone from this wall and using some of the modifiers inside 3ds Max, we can recreate the other part of this stone. Even better, we can use some of the modifiers inside 3ds Max, like for example, the new retopology tool, to work and recreate a whole section. We can use that section as an element on its own and cut it to an exact length that we need to make a module. If we create a couple of modules which are following exactly the same rules in terms of size and as well of pivot points where they stitch, we can easily create a couple of modules. Having exact measures and knowing exactly where those modules need to be placed is the first step that we need for creating a procedural content. Now what you're seeing inside my 3ds Max scene is a group of assets and elements that are being created from different modules. All of these modules have been through the same treatment. There is a certain asset in real life that has been scanned, and after that it's been edited and processed inside 3ds Max to create a low poly version, and later put into some kind of a constraints in terms of a grid, so we can put those into different segments that can be attached based on some logic. For example, we have the bottom part of a column or a round part of a wall, and as well we have the wall itself. We can of course extend it at any point higher or make it lower, and also based on a couple of different ruins that we scanned in the same region, we can put an ending on this element. The combination between those two elements and as well the ruins that we have scanned ends in a result of creating this column. We can of course use the same method and extract a portion of the wall, plus combine a little bit more of the ruins that we have on the side, and get a different type of version. By scanning more data for all the walls and all the different parts, we can then add different randomization. For example, here you can see that we have such ending for our element, but here on the final asset, we have two different versions. We have this one, which is very similar to this, with just a couple of differences. And then we have this one, which you can see that has a couple of different holes. This is because we scanned different type of such elements, and using those elements, we can then randomize them and create something unique. At the end, to create an asset which is usable for games and to have a very nice topology, I use the 3ds Max retopology modifier. This helps me bring all of these different elements which have been assembled here from different parts that have been scanned and create new nice asset with a clean topology. I'm going to turn on my wireframe to show you what I mean. You can see the geometry is full of quads, so this makes it with nice loops and makes everything very clean and easy to edit. As well, if you want to create a unique set of UVs specifically for this asset, it's something which makes it a lot easier. The topology makes it a lot easier to create those UVs nice and clean. I tried in the past different methods for creating such topology and making my low polys easier and automated before getting them inside the game engine, but using the 3ds Max retopology tools gives best results, as you can see. Using the same type of data and scanning more parts of walls and as well more of the ruins, we are able to create different type of assets and different type of elements. Everything that we need for second part of creating this algorithm is how exactly those different stones and those different elements that we have scanned are combined together. So for example, using a little bit of the scanned walls over here, some of the ruined parts, and separating some of the stones for creating an arc for doors or windows, we are able to curve and create assets that look like this. Seeing all of these elements, you can see how powerful this tool is. We can just take a different part from a scanned asset, create it with a certain measures, and after that use it a couple of different times, rotate it, randomize a little bit the texture patterns on top of it, and at the end we can get a different variations just from a couple of scanned assets. Of course, the more scanned data we have, the more different versions and the more randomized your assets are going to look like at the end. Now I want to talk a little bit more about the logic behind how exactly we can assemble a whole wall from just a couple of scanned assets. So in this example, I'm going to talk a little bit about the algorithm and what we take into account. So in this example, with a very simple geometry, I'm going to show how exactly we process this data and how we assemble a whole wall. So in the case, you can see here, we have three different assets. All of them are meant to be rocks. All of them are meant to be stones, which are going to build a wall. So we have a small one, a large one. So this means that those two assets, since we know their measurements in terms of width, length, and height, we can determine what is the volume of the asset and place the other one outside this volume. So for example, this is going to be like that. And then if we have another asset, it's going to come on top of it. Again, we are measuring the asset volume, so it's something which is not going to interfere and intersect. When we are creating a wall from tiles, which are regular ones, and we know exactly the size and they are not irregular shapes like this one, in this case, we are just using a fill in between. So this is a plane which is being spawned a little bit deeper from the outer layer of those rocks, and it's just going to be the filler between all of these stones. But when it comes to irregular shapes, we can of course have different sizes, and not always we can put everything perfectly. So sometimes they might intersect, or sometimes there might be a little bit of a distance in between. This is something which, again, we are dealing of putting a plane which is going to be with a certain material on the back, and this plane is something which is going to fill all the holes. Or in the case that we are intersecting, we make sure that this intersection is not a lot. So in case of the irregular shapes, since we can't know exactly each of the corners where it's standing, we are taking the boundary box. So we are having the boundary box, we take that into account, and we put a little bit of a blending in between. So in the case of having such irregular shapes, there is going to be a couple of centimeters blend in. So this one can intersect with this one. This helps create more organic and more natural looking shapes. The showcase that you're seeing at the moment is using irregular stones, and it's something that uses the logic to create a whole wall just from a couple of different scans. It's randomizing them, making them into different shapes and sizes, and as well it's putting a little bit of a different noise and texture overlay on top to create different patterns and to randomize how the textures look like so that you don't see a pattern repeating. After creating the base from all of the stones, we can use different types of assets to lay on top, which are going to further randomize and further improve the visuals for this asset. In this case, we can put some vines or moss. At the end, using this technique, we can create a lot of different variations of assets, later on further optimize and improve the assets so that they are game ready, export them and import inside game engines like, for example, Unreal 4. The scene that you're seeing on the background is something which we assembled as a small demo, and it's using an assets which have been generated based on the scan data and as well on the architectural research from that region. Now I want to talk a little bit about the application for such technology and what will be the further development of it. At the moment, it's something which from my side, I'm creating a database and experimenting in how exactly we can extend and all the different possibilities of combining different types of meshes. And as well, I'm teaching the AI how exactly to create different types of assets and build them the way that people are building them. This is a tool which, in combination with the Autodesk products, can bring a lot of automation for architectural visualizations, building scenes for cinema, or building huge environments for games. Nowadays, the scenes and the demand of such assets is becoming bigger and bigger, and as well, the content that studios are creating is becoming more and more. This is a tool and a research which is meant to help artists in future to develop faster, more randomized, but architecturally correct assets and areas. Thank you for joining me in this year's Autodesk University. I'm Stefan Ivanov, and see you next time.